Okay, guys, today should be a pretty straightforward day. Um, After I briefly review what we talked about last week, today is going to be mainly a conceptual day where we're going to just be going over types of forces and the various types of forces involved in physics, at least the forces that you're going to see in a first year physics course. And then after that, I am going to post a Schoology assignment, which is a multiple choice assignment with about 16 questions ready for you guys to complete. Okay, so that's what's on the agenda for today. Okay, so briefly reviewing last week, last week we talked about how to interpret free body diagrams, which is just another word for force diagrams, and we talked about how you can have one free body diagram which could explain multiple situations, like is the object slowing down, is the object speeding up, is the object moving at a constant velocity, is the object is at rest. That's basically what we talked about. Um, so briefly, I want to go over those few situations with you all today. So give me just a second while I pull up last week's material. And then I'm just going to take about a minute reviewing that. Then we're going to, of course, get on the main topic for today. So, here were several examples that we looked at last week. So, for example, we said that considering situation one, what would be the possible scenarios this free body diagram could be depicting? And notice here's number one says this object is just sitting on a table and there are balance forces acting on it. Remember, guys, if there are balance forces acting on your object, Newton's first law says that an object at rest should stay at rest. So this object is just at rest sitting on a table. Okay. Let's look at another situation. What about number 2? It says this object is moving vertically. Okay, and here there are unbalanced forces acting on our situation. So we know we have some sort of acceleration taking place. If it's moving vertically, guys, remember what vertically means. Vertically means it can be going either up or down. Remember, if it's going down, the object will be speeding up because it's moving in the direction of the dominant force. If it's moving in the positive direction, that means the object is slowing down because it's going against the direction of the dominant force. So again, those are just things that we talked about. Let's deal with another scenario here. So number 8 says this object is moving horizontally. So our object could either be moving to the right or it could be moving to the left, because that's what horizontally means. So if it was moving to the right, it'd be speeding up. If it would be moving to the left, it'd be slowing down, because if it's moving in this direction, it's moving in the direction of the dominant force. If it's moving in this direction, it's moving opposite the dominant force. So y'all got that? Okay. So again, just various scenarios that we talked about. Looking at number 4 says this object is in motion to the right. So, and notice we have balanced forces acting on our object. There are no unbalanced forces here. So Newton's first law says that an object in motion should stay in motion. So specifically what you would say here, the object is moving at a constant velocity. Okay. And then lastly, I want to share with you guys on the review, we looked at various real world situations that you guys need to be aware of. So we gave give me just a second while I look for these videos. So I showed you guys this clip. Of a person bungee jumping. Okay, so and guys, remember what we talked about last time? If Lexi is bungee jumping, okay, right here, the dominant force acting on her will be gravity, because on, give me just a second. So the dominant force right now acting on Lexi would be gravity. So I'm just going to put a G for gravity. Okay. And so as Lexi falls, the moment she starts falling, since she's moving in the direction of the dominant force, she's going to be speeding up in the negative direction. But then notice as she continues to fall, this rope here that she's attached to tightens, and so we've introduced another force, which we're going to call that force tension. So, and I'm going to put a T for tension. And the tension force is larger than gravity. So as long as the tension force is larger than gravity, in this case right here, she's going to be slowing down. And you know she's slowing down here because she doesn't fully go into the water, right? So this dominant force here of tension is resisting her motion. So she's slowing down in the negative direction. Then she comes to a stop for a brief moment of time. And then she begins to speed up in the positive direction. Okay, because here she's acting in the direction of the dominant force. Okay, so just situations to consider. Okay, so how the point is, notice how this free body diagram is describing more than one situation. Here, Lexi is she's either slowing down in the negative direction or she's speeding up in the positive direction. So notice she's slowing down as she moves opposite the dominant force, but she speeds up if she moves in the direction of the dominant force. Okay, so just something you guys need to keep in mind. Okay, now before we get to our main topic for today, one more thing that I want to go over. I want to be sure everybody is convinced on how to calculate an object's weight, because some of your homework assignment problems will involve you calculating weight. So let me go ahead and share my screen real quickly to get to that. Okay, let me pull this up. Okay. Now, okay, why is this not showing? Okay, let's try this again. There we go. Okay. Now, okay, guys, imagine this is me, and I'm standing here, and I'm standing on the earth. Okay, and while I'm standing on the earth, what if I wanted to know my weight? Okay, well, it's obvious. If I wanted to know my weight, I would stand on a scale. But what exactly is the scale measuring? Okay. So, guys, it should be obvious to you that if you're standing on the earth, the reason why you're able to stand on the earth is because there's a force pulling you downward. Okay. Okay. This force is obviously the force of gravity. Okay. And so, remember, gravity always pulls objects toward the center of the earth. So this force right here, gravity, is pulling me toward the center of the earth. In other words, it's pulling me on that scale that I'm standing on. So basically what you can say is the scale is indirectly measuring the force of gravity. So if you want to know your weight, all you do is just calculate the force of gravity acting on you. So, okay, if you guys remember, and I'm going to write this equation down, the force of gravity is equal to mass times what? Can someone tell me what is the equation for the force of gravity? This is anyone? So the equation for the force of gravity is equal to mass times 9.8. Mass times 9.8. So now to make my calculations easy, I like to round 9.8 off to 10. Okay. So guys, you're going to use this equation a lot in your homework assignment for this afternoon. Force of gravity is equal to mass times 9.8. So let's just say my mass. So let's just say my mass here is 75 kilograms. Okay. Okay. Obviously, if I have a mass of 75 kilograms, then that would mean that my weight is 750 newtons, because 75 times 10 is 750 newtons. So of course that's my weight in newtons, not in pounds, but in newtons. So remember that, guys. Anytime you want to know an object's weight, you just calculate the force of gravity acting on the object, because basically that's what weight is, right? When you set on a scale, the scale is indirectly measuring the force of gravity pulling you. And you know that because, if gravity was pulling at you stronger, with a stronger force, then that would mean that you would have a greater weight. So if you go to a planet such as Jupiter, which has a larger gravitational pull, your weight will be larger on Jupiter because of that pull. Okay. Now, now that we've gone over all of those concepts from last week, today I want to focus on types of forces. Okay, types of forces. Now, as soon as we are done with class on today, as soon as we're done with class, in the Monday folder for today, I am going to post these notes here. We've already gone over Newton's 3 laws of motion. We've already gone over Newton's 3 laws of motion. But today we're going to focus on the common forces in physics. Okay, because guys, we're these common forces in physics, these are going to be very, very important, because we're going to talk about these forces throughout the year. And plus, guys, your homework assignment for today will basically just involved, basically seeing if you guys understand when all of these forces or these types of forces appear on a free body diagram. Okay. So you need to know when these forces are present in particular situations. Okay. The first few forces we've already defined, but I'm going to kind of define them in more detail. So the first force is the force of gravity. Okay. And the force of gravity is basically the force of attraction between two masses. Typically in this class, when we talk about the force of gravity, we're speaking almost exclusively of the force of gravity caused from the Earth pulling on other objects around it. Okay. Now, guys, everyone in here knows that the Earth pulls on you. I mean, it's obvious, because that's the reason why we all stay on the Earth. But what may not be obvious to you all is that this gravitational force of attraction, it appears between any and all masses. So, for instance, let us imagine that you're sitting right now at your computer and you're watching this lecture. Okay, and let's say, I don't know, hypothetically, you had a little sister. She was right next to you right now while you are watching this lecture. Okay, since both you and your little sister are masses, you guys are both attracted to each other. You both are literally pulling on each other, kind of like two magnets pull on each other. You both are literally pulling on each other. Okay, but if that's the case, why is it that we don't detect this force in our everyday lives? Well, guys, it turns out that you and your little sister, because you guys are so much smaller than the Earth, that force of attraction, that force of gravity between you two, is extremely small compared to the force of attraction between you and the Earth. So it turns out you are pulled more toward the Earth than you are to your little sister. And so that's the reason why in our everyday life, we tend to not notice this force of attraction between um, objects of roughly equivalent masses. But just because we don't notice it doesn't mean it doesn't exist. I mean, we know it exists. We've actually measured it. We know this force exists. In fact, every object in the universe pulls on every other object. Okay, because right now, whatever object is next to you, you are pulling on that object with a gravitational force, and that object is also pulling back at you, according to Newton's third law. Okay? But again, because the Earth is so much larger than you are being pulled more toward the Earth than you are to those other objects. Okay? So that is the force of gravity. So that's an important force you guys need to know in this class. Okay? Another force you guys need to be aware of, and this is something that we also talked about last week, is the normal force. And this force is caused by two objects in direct contact with one another. It results from one object pressing against the other, and it is always perpendicular to the surface of contact between the two objects. So let me give you guys a few examples of this, because we did talk about this. Give me just a second while I pull up this PDF file, because this is another important force you're going to see in this course over and over and over again. Okay, guys, give me just a second while I pull up this commie file. Okay, let me stop sharing my screen and then share the share this file with you all. Okay, so guys, remember what we talked about last time? Imagine this block here. There's a block and it's sitting on a table. Okay, if the block is just sitting on the table and it's in contact with this surface, not only is gravity pulling down on the table, there's obviously another force acting on it that basically prevents it from going through the table, and that force is the normal force. So clearly there's a normal force pushing up on this surface. Okay? The normal force is always perpendicular to the surface of contact. If this right here represents the surface of contact, then the normal force is always 90 degrees relative to that surface. So, for example, let me go down to the bottom here. Okay. So, guys, imagine where you had a situation right here where a block is sitting on an incline. Okay. So this right here, this represents the surface of contact, and the block is just sitting there. So that means the normal force right here will be pointed like this. It's going to be pointed at an angle. Okay. You guys got that? Because the normal force is always perpendicular to the surface of contact. If this is your surface of contact right here, and the normal force is pointed in this direction, it points in a direction 90 degrees relative to this surface. Okay, so you always get a normal force whenever you have two objects that are touching one another, and one object presses against the other object. Okay, and my lights just went out. Okay, let me turn on. Okay, there we go. And what if we had a situation like this, guys? What if we have what if we had an object that was leaning up against the wall? So let's say someone was pushing this object against the wall, and we wanted to find the normal forces acting on this object. Let's say this is a book or something. Okay. So guys, if this is the surface of contact here, that means the normal force must be acting like this in this direction. So, because the normal force is always perpendicular to the surface of contact, always. So what that means is that in this case, okay, the normal force looks like this, where, because this object here is in contact with this surface, and it's pressing against this surface, and so that means, according to Newton's third law, if this book presses against this wall, then the wall must push back on the book. So that is the normal force. Okay. And the normal force, so it's always a pushing force. It's always a pushing force. That's different from tension, where tension is always a pulling force. And again, we're going to talk more about that in a moment. Hold on, I just realized I wasn't sharing. I wasn't sharing my screen with you all when I was, when I pulled up the notes. Anyway, let me repeat what I just said. Okay, there we go. So the normal force is always a pushing force. So it's always a pushing force. And again, that's different from tension, which is always a pulling force. Okay, but we're going to come back to that. Okay. All right, guys, we're going to okay. Let's So we're going to explain about 3 more forces, and then I'm going to kind of touch on the various types of friction, and then we'll be done for the day. Okay. So this should take about no more than hopefully no more than another 10 or 15 minutes. So guys, bear with me. Okay. So moving right along to the force of friction. The frictional force is the force exerted by a surface on an object as the object moves across it or makes an effort to move across it. It may be helpful to remember that friction acts opposite the direction of motion. Okay, so guys, anytime you have 2 objects sliding across each other, there's always a force of friction there. Okay, let me show you guys an example of what I mean. So, I always like to show video clips because video clips always help you guys solidify these concepts. Okay, so so guys, look at this example here. Hold on, guys, give me just a second while I'm gonna put that video on replay. Give me just a second. Okay, let me get ready to share my screen. Okay, so we're talking about the force of friction. Okay, what is the force of friction? Okay. So guys, notice here in this situation here, notice how I have a block here sliding across the surface of this wood. Okay, and guys, as the block slides across the surface, there's a frictional force between the block and the surface. Okay. Now, remember, guys, the key to remember about friction is that friction always acts opposite the direction of motion. Okay. So in this situation right here, okay, the block is sliding toward the right. So that means if the block is sliding toward the right, it should be obvious to you all. I didn't mean to stop it. Hold on, guys. If the block is sliding toward the right, it should be obvious to you guys that that means there's a force of friction. Hold on, let me. If the block is sliding to the right, it should be obvious that there's a force of friction that is acting to the left. And hold on, guys. Give me just a second. I'm making this screen big enough for me to write on. Okay. So there's a force of friction acting in this direction. Okay. So there's a frictional force. Okay. Because friction always acts opposite the direction of motion. Always. So So again, the block is sliding across the surface, and if it's sliding to the right, friction is acting toward the left. Okay, so keep that in mind, guys. Friction always acts opposite the direction of motion. Okay, let's move right along. Okay. Now, okay, so we just talked about the force of friction. Now let's move on to air resistance. Okay, what is air resistance? Air resistance is a special type of frictional force that acts upon objects as they travel through the air. So this is the key here, guys. Air resistance is a special type of friction. Okay, so we discussed air resistance last time. Remember how I showed you guys the video of me skydiving? Let me go ahead and show that clip again. Okay. So let me pull that up. So I showed you guys this video last week of me jumping out of an airplane. Okay. So as I go to jump out of the airplane, okay, guys, we've already talked about how there's gravity that is acting on me. But not only is there gravity acting on me, there's also another force acting on me, and that force is air resistance. Okay, so I keep going. So you guys clearly see that as I fall, air is pushing up against me. We call that air resistance, and it is a special type of friction. Why do we say it's a special type of friction? Because, guys, remember what I just said, the frictional force always acts opposite the direction of motion. So it should be obvious to you all that if I'm falling in the negative direction, I'm falling down, it should be obvious to you guys that air resistance acts in this direction. Okay, so so air resistance is a special type of friction that acts on an object while an object is in the air. So it acts on an object while an object is basically when an object's in free fall. So here I'm falling in the air, and remember, friction acts opposite direction of motion. And since air resistance is a type of friction, if I move in the negative direction, in this case, air resistance acts in the positive direction. Air resistance always acts opposite the direction of motion. Okay. All right. So let me stop sharing that. Okay, one more force that we need to talk about. Okay. And of course, guys, I've already mentioned this force to you all when I showed you all the video of Lexi bungee jumping. And this force here is the force of tension, or in other words, the tension force. And this force is the force that is transmitted through some sort of string, rope, cable, or wire when it is pulled tight by forces acting from opposite ends. So it may be helpful to remember that tension is always a pulling force acting on your object. Okay, so guys, the force of tension is the pulling force that always results whenever you have a string or rope or cable or something like that. So it's the force that is transmitted through that string or that rope. And of course, we saw that example with skydiving. But what are some other examples of the force of tension? Okay. Give me just a second while I pull up these diagrams that I had. Okay. So, okay. Guys, imagine this block here, and someone's pulling this block and is pulling this bucket here. So guys, if we want to find the forces right now acting on this bucket of water, that would be obvious. I mean, we know gravity is acting on the bucket because gravity pretty much always acts on objects here on Earth. But there's another force acting on the bucket, and that is the tension force. There's a tension force from this rope here. So let me draw that force. Okay. So there's a tension force pulling up on the bucket. Okay. And that's the force that is acting on this object right here, this bucket of water, the tension force. Tension is always a pulling force. Always, guys. Um, um, Tension is never a pushing force, it's a pulling force. So, for example, guys, what if I wanted to know the tension force right now that is acting on this block here? So, I'm just solely looking at that object. Okay. If I want to know the tension force acting on that object there, I would always draw the force acting away from the object because tension force is always a pulling force. So this rope here literally pulls on this object in this direction. So tension force is always a pulling force. And of course, if the block is traveling in this direction right here, there's a net downward force such as gravity or the person pulling on it, but still there's also a tension force from the rope acting on the block. Okay. Okay. But guys, keep in mind though that the tension force, we can get an idea of what's happening with various objects that make up our system if we consider Newton's third law. For example, we know that not only does the rope pull on the bucket, but the bucket also pulls on the rope. So if I had to look at this part of the rope right here, okay, so if I just had to focus on this part of the rope right here, there's clearly a force of tension from the bucket pulling on the rope, and that force looks like this. Okay? Because that's Newton's third law. For every action, there's an equal and opposite reaction. Not only does the rope pull on the bucket also pulls back on the rope. Okay, so just keep it in mind that, that is the force of tension. Here's another example of the tension force. Okay, guys, imagine a situation where two people are playing tug of war. Okay. Okay. So imagine a situation where two people are playing tug of war. Okay, you guys are familiar with tug of war. If both people are, pulling at this rope, okay, if I want to know the forces acting on this guy and the forces acting on this guy, in the horizontal direction, that will be obvious. That's just a force of tension because, there's a rope there. So they're both pulling on each other, right? Because that's Newton's third law. If this guy pulls on this guy, then this guy pulls back. So, if I wanted to know the force right here now acting on this guy, okay, then I would draw that force looking like this, okay, because there's a rope there, so there's a tension force pulling on this guy right here, okay. But what if I wanted to know the force acting on this guy right here? He's also connected to this rope or this string. So that means if I want to know the force acting on this guy, I would draw my tension force like this. Tension is always a pulling force, so it always points away from your object. So, right, that's just Newton's third law. Okay, if this guy pulls on this guy here, then Newton's third law says then this guy must also pull back on this guy. Okay. So they're both pulling on each other, right? That's Newton's third law. So there's clearly a tension force from the rope as a result of them pulling on each other through that rope. Okay. So, okay. Now, last thing that I want to talk about today before I let you guys go is this right here. is the various types of friction. So we talked about friction above, and we said that friction always acts opposite the direction of motion. But there are three main types of frictions you guys need to be aware of. And all of these types of frictions act opposite the direction of motion, or opposite the direction of, um, how do I say it? Um, Opposite direction of motion the object wants to travel, assuming it's at rest. Okay, so the three types of friction you guys need to be aware of are static friction, kinetic friction, and air friction. We've already talked about air friction, but I want to elaborate more on static friction, kinetic friction. And of course, this is the last thing we're going to talk about today. Now, guys, what is the definition of static friction? Static friction is the force that resists an object while it is at rest. Kinetic friction, on the other hand, is the force that resists an object while the object is in motion. In other words, while sliding against another object. Okay, so let me give you an example of what I mean by this. Examples always help. Okay, so guys, imagine this kid here trying to push this really, really large box. Okay, so if he's trying to push this really, really large box, okay, now obviously, guys, it should be obvious to you that, you know, to push this box, he will have to put a lot of effort into this box. It's just not enough for him to just to push on it with little strength. But guys, let us suppose that he pushed this box. He just gently pushes it and he noticed the box doesn't move. Well, why is it that the box doesn't move? The box doesn't move because there's friction between the surface of the floor and the box itself. And that friction is what we call static friction, because static friction is the frictional force that resists the object while it's at rest. Okay. Now, if this guy starts pushing even harder, and he pushes and pushes and pushes hard enough, he noticed that the box starts sliding. Okay. Right at the moment that the box starts sliding, that's when kinetic friction kicks in. Kinetic friction is the frictional force that resists the object while the object is in motion. Okay. So I'm going to say that again, guys. If this guy pushes on the box and the box doesn't move, okay, the reason why it's not moving is because there's a force of static friction here. And let me draw that better than that. There's a force of static friction resisting the motion of this object. So static friction. Okay. So right now, if the box is not moving, static friction is resisting the motion of this object. And so, or in other words, it's resisting the object in the direction that the object wants to move. Let me say that, because it's not the object's not in motion; it's at rest. So the force resists the object in the direction that the object wants to move. So that is static friction. Now, the moment he pushed hard enough, he pushes, and this box starts sliding. Okay. Now that's when kinetic friction kicks in. Okay. So I'm gonna say that again. If he pushed hard enough, and this box starts sliding, now at this moment, kinetic friction is what is resisting the object's motion. So here, while the box is in motion, we call that kinetic friction. So as long as he pushes hard enough, at a certain point, he can overcome static friction, and kinetic friction kicks in. Okay. Hopefully that makes sense. Okay. So static friction is the force that resists an object while it's at rest. It is the force that must be overcome in order to start motion. I'm gonna highlight that term there. So the static friction force must be overcome in order to start motion, because static friction is the friction force that resists an object while an object is at rest. Kinetic friction, on the other hand, is the force that resists an object while an object is in motion and sliding against the surface of another object. Okay, so remember that. Now, guys, both static friction and kinetic friction depend upon the roughness of the surface. Okay, so because of irregularities on the surface of objects, this causes objects to grip to the surface of other objects while they move across one another or attempt to move across one another. So let me show you guys a video of what I mean by, not a video, but a diagram of what I mean. So okay, so if I guys, it should be obvious to you that if I took a crate here and I attempted to slide this crate across this block here, it should be obvious there's a force of friction between those two surfaces. But guys, do you all know what causes friction? What causes the frictional force is irregularities in the surface of the object. It looks something like this. Guys, if I have to zoom in to these two surfaces here, like if I had to zoom in and shrink myself down to the smallest of scales and zoom in, I would notice that these surfaces are not perfectly smooth. There are irregularities in the surface, and these irregularities is what causes the frictional force. Basically, it will cause us that resistance as you attempt to slide one object across the surface of the other object. So in other words, it's these irregularities that causes the objects to grip against one another. This is what causes friction. So in other words, guys, the smoother your object, the less the force of friction between the two objects. So obviously, imagine you're trying to slide across ice. Since ice is a relatively smooth surface, it's pretty much it's almost nearly completely smooth. There's very little friction if you try to slide across the surface of ice, because ice is pretty much smooth. Now, guys, ice is not perfectly smooth. In fact, there's no such thing as a 100%. Well, there's no such thing as an object that is just completely smooth. You can never get an object that is just 100% smooth, where there are no irregularities in the surface. You can come close. In fact, NASA have designed spheres that come close, but again, it's just impossible to achieve a 100% smoothness. So all objects, if they attempt to slide across some form of object, there's some sort of frictional force involved. But again, the smoother the surface, the less the friction. Okay, so the frictional force depends upon the roughness of the object's surface. And obviously, since ice is pretty much smooth for the most part, ice has very little friction. Okay. And okay, so those are your three main types of friction. We've already talked about air friction. Another word for air friction is just air resistance. And remember what we said, this is the special type of friction that acts on an object while an object is traveling through the air. Okay, so these are the three main types of friction. And friction always acts opposite the direction of motion. Or in other words, in the case of static friction, it acts opposite the direction of motion. Well, it acts opposite the direction an object wants to move while it's at rest. Okay. All right. Are there any questions for me? Okay, guys, give me about 10 or 15 minutes and I'm going to have the assignment posted in Schoology. What else? Yeah, give me about 10 or 15 minutes because there's a few things I have to get done to get that posted. If there are no questions for me, you guys are free to go. I'm going to keep the Zoom call open until 9. I'm going to keep the Zoom call open until 9:11. Okay. Yeah, have a good day, okay? Take it easy.